Hello everyone, I am Emir Kerem Tel. Today I'll present my Physics 102 project on wireless power transfer. We use wireless charging every day, but efficiency drops when devices aren't perfectly aligned. The aim of this experiment is to see exactly how angular misalignment affects this power transfer. Based on Faraday's law, induced voltage depends on the magnetic flux, which follows a cosine theta relationship with the alignment angle. Since power is proportional to voltage squared, we expect the output power to follow a cosine squared theta model. My goal is to verify this theory experimentally. Here you can see the experimental setup in the laboratory. I used a fixed transmitter coil connected directly to an AC power supply. The receiver coil is connected to a digital multimeter set to measure AC voltage in millivolts. I placed the receiver coil at a fixed distance and rotated it manually using a cardboard guide from 0 degrees, which is perfectly parallel, to 90 degrees, which is perpendicular. As you can see in the footage, holding the coil by hand causes the voltage readings on the multimeter to fluctuate due to minor hand movements. To minimize this random error, I recorded 5 readings for each 15-degree increment and used their arithmetic mean for my data analysis. Looking at the results, the graph shows voltage dropping non-linearly as the angle increases. To test our theory, I linearized the data by plotting the squared voltage against cos squared theta. As you can see in the second graph, we get a clear linear trend. This strong correlation verifies Faraday's law for this geometry. However, experimental values were much lower than theoretical predictions at higher angles. The theory assumes a perfectly uniform magnetic field, but our coils actually produce a divergent dipole field, causing a steeper drop in flux. Also, manual alignment causes systematic errors. For instance, at 90 degrees, I read 17.2 millivolts instead of 0. This is due to the difficulty of holding it perfectly perpendicular by hand and ambient noise in the lab. In conclusion, the experiment successfully showed that the power transfer efficiency drops with angular misalignment, following a cosine squared theta trend. It also highlighted that real-world setups must account for non-uniform magnetic fields and physical alignment limits that ideal models ignore. Thank you for watching.